We're going to be taking a look at the quadratic formula. Now, it might look a little bit scary, but it really isn't bad once you get the hang of it.
The quadratic formula is used to solve quadratic equations that look like this. Okay, now where does the quadratic formula come from? I'm not going to burden you with all the details. I'm just going to tell you that the quadratic formula, which is this, comes from the quadratic equation, which is that. There is a process by which you can turn one into the other. So that's where it comes from.
If you take a look closely at a quadratic equation, you'll see that it has equals 0. That's really important. You have to make sure that it's in that form, same as we put it in that form for factoring. Also notice that the coefficient of the x squared is a, the coefficient of x is b, and the number that's all by itself is c. That's what we call a, b, and c. Now, if you look at the quadratic formula over here, you'll see that we have a bunch of a's, b's, and c's in it. And the numbers that we put in there come from the quadratic equation. So here I have a quadratic equation, and notice that I have this equals 21 thing over here. We cannot have it equal to anything but 0. We need to subtract 21 from each side. So that gives me x squared plus, now notice that these two are not like terms, so we do not combine them. We just write them as they are, 4x minus 21, and then equals 0. So now my equation is ready to be put into the quadratic formula. Now, before I can do that, I need to figure out what a, b, and c is. Now, if we look over here, the coefficient of x squared is 1, so therefore a is 1. The coefficient of x is 4, so b is 4. The number that's all by itself is negative 21, so c is negative 21. And now we are ready to go. So I'm going to write x equals, I'm copying from here, x equals. Now instead of negative b, I'm going to write negative 4 because my b is 4. Then I'm going to write plus or minus. I'm just copying it down. Then I have square root b squared. So my b is 4, so I'm going to write 4 squared. And then minus, and then 4ac. So 4 times my a is 1, my c is negative 21. And then all of that goes over 2a. So that's 2 times 1 in this case. Okay, so that's what I have right now. Now, what I like to do is I like to solve what's inside the square root first so that I don't have to keep rewriting the formula over and over again. The expression that's inside the square root is called the discriminant. So I'm going to go over to the side and I'm going to write the discriminant down. I have 4 squared minus 4 times 1 times negative 21. And let's see what that is. 4 squared is 16. We have a minus and then another minus right here, and they're multiplying, so we're going to get a plus. So then I have 4 times 1 times 21. So when you multiply that, you're going to get 84. So then I have 16 plus 84, and that gives me 100. Okay, now I'm ready to rewrite my quadratic formula. So I'm going to write x equals negative 4 plus or minus. Now remember, all that stuff in the parentheses is equal to 100. And all of that over 2, because 2 times 1 is 2. Now I'm going to simplify even more. Square root of 100 is 10. So now I have -4 plus or minus 10 over 2. Right? I'm going to make some space on the side. 1 second. So now I have two answers. I have -4, or x equals -4 plus 10 over 2, and I have x equals -4 minus 10 over 2, because that's what this plus and minus means. Okay? So now I'm going to separate them so I could see what the answers are. So -4 plus 10 is 6 over 2. So that equals to 3. And so my first answer is x equals 3. And my other answer, I have -4 minus 10. So that's x equals -14 over 2, which is -7. So x equals -7. So my two answers are 3 and -7. Now, before I move on, I want to show you that you would get those same answers had you factored this equation. Okay, so I'm going to start with the equation that we got originally, x squared plus 4x minus 21 equals 0, and we're going to factor it. Now, remember, we need a product of -21 and a sum of 4. Okay, so what two numbers give us 21 that have a 4 difference? Well, it's either -7 times 3 or +7 times -3. And when I add these together, I get -4, +4. So this is the pair that we want. So I would have x plus 7 and x minus 3 as my two factors. And then I would set each one equal to 0 and solve. Here I have x minus 3, add 3, x equals 3. So I just wanted to show you that the answers that we got, x equals -7, x equals 3, were the same as we got with the quadratic formula. Now, you might be asking, well, why in the world would I do the quadratic formula if factoring is so much easier? Well, that's because not every equation can be factored, and some solutions are very complex. And so you can't factor, you have to use the quadratic formula. So that's why. Now I'm going to quickly go to Desmos and I'm going to type this equation in. X squared plus 4x minus 21. Remember, you're not writing equals 0, you're writing equals y. And when you take a look at the x-intercepts, you get -7 and 3. And once again, all these words are pretty much the same. Solutions, x-intercepts, roots, and zeros. And notice, no matter whether we graphed it or whether we use factoring or whether we use the quadratic formula, we get the same answers, x equals 3 and x equals -7.